Welcome to GTXplorer. This is an interactive portal to visualize and mine evolutionary data for glycosyl transferases with the GTA fold. We're on version beta 1.0.0. We've included a navigation tutorial. You can click this and be able to watch this video and figure out how to navigate, access, and download this evolutionary information for protein sequences of GTA families. There are two ways to navigate. We have a tree view and an alignment view. In the tree view, you can click on this link to look at the phylogenetic tree. You can look at clades and families with a pop-up card for all of this family-specific information. You can click on the alignment view to see stacked alignments of clades, families, and subfamilies for cross-comparison of conserved pattern positions and for publication quality figures. You can click on this GitHub link to get the entire project and download it. It's an open source project, and you can run the server locally on your computer. Starting from the tree view, we can look at the entire phylogenetic tree in context of the relationships between GTA enzymes. We can see each of these clades as defined by a previous paper in eLife. The link is cited in the video. So clade 8, clade 6, we can see all of these individual GTs, and if we click on any of the clades, we can see a little pop-up box appears that includes a description of all of these families that are in each clade. And so this clade includes only inverting families, for example. We can download each of these families' sequences in terms of domain, full sequence lengths, or table of both. And we can download specific sequences to NR database or to UniProt database. Finally, there's a taxonomic distribution of each of these enzymes where they come from. So you've got 10,000 sequences in bacteria, 6,000 sequences in metazoa, so on and so forth. Then we have a family alignment of all of these sequences in this clade. And you can download all of the sequences from NR or UniProt from the bottom here. Going further, we can exit out of that, and we can click on individual enzyme families as well. So if I click on GT43, for example, I get a little description about what GT43 is. And these enzymes are labeled after the KZ database naming scheme. Tells me GT43 is an inverting mechanism. Tells me what subfamilies belong to GT43. And I can download individual domain sequences for each of those subfamilies, full sequence, and a table of both, just like before. And these are all separated by NR and UniProt databases. Domain organization is also provided, so you can see that 38.9% of these sequences have GTA domains, 56% have other GTA domains or transmembrane helix included in the sequence. And then taxonomic distribution information is also included. So we can say 1924 sequences in this family are from metazoa. As above, in the clades, you see that there is a sequence alignment provided. These sequence alignments are aligned to the consensus sequence, which I will show next. But you can see the DXD motif, the common metal binding motif for GTA enzymes, is located right here, and you can look at other family-specific motifs through this. Next up, I'm going to show the alignment view of GTXplorer. Clicking on the link, I'm brought to this page, and this is the first thing I see, which is the consensus sequence, which is 231 aligned positions of the GTA enzyme. On the left is in a hierarchical panel that essentially allows me to look at all of these sequences in terms of clades, or I can click on the little icon here to create a drop-down list and look at each individual family. If the family has multiple subfamilies, then I can click on this link again and look at the individual subfamilies. I can choose to visualize at the clade level, the family level, or the subfamily level. At these three different visualization points, I can look at how exactly what the pattern positions are. I can look at how it matches to the consensus sequence, so on and so forth. At the top here, I can see various settings. For example, height. I can change the height to make it a little smaller or to make it bigger, depending on what I'm looking for, but we'll keep it at 100 for now. I can see motif. I can see hierarchy. All hierarchy does is hide this panel on the left or bring it back. Motif allows me to click on this, and then I can see a legend over here that tells me, okay, this is where the DXD motif is, this is where the G loop is, this is where the XED motif is, so on and so forth. And these are all motifs that are critical to the GTA enzyme. Then I can create domain structure that tells me, okay, this beta alpha region is the beginning of the Rosman fold of this enzyme. And this, of course, is common to all of these enzymes. So all of these enzymes are numbered in relationship to the consensus sequence, meaning this is where the beta alpha regions are for this sequence, whether you're subfamily, family level, or even clade level. There are a number of other options available as well. If I scroll up, let me hide the domain structure and motif for a second. Now, these patterns just tell you the pattern positions that are conserved in these GTs. But if I don't want to look at them right now, I can click on the pattern position and they disappear. If I want to change the reference position to a particular sequence, I can look at all of these and I can say, okay, well, I want all of these sequences in reference to a particular sequence I'm interested in. So in GT84, I might look at this sequence in particular. And so suddenly all of these are numbered in reference to that sequence. And I can change all of these to represent that as well. If I don't want to look at a sequence anymore, I can click on the little trash icon and it just deletes it from memory. If I want to bring it back, I could just go here, click on the sequence again, and now it's back. If I want to change the location of these sequences around, I can click on this little set of 4 lines and then just move it around as I feel. Let me delete all of these for now and bring back only the GTA sequence. Now, if I'm interested in downloading these sequences, I have a little download option right here that lets me download NR reference sequences. And then finally, if I'm interested in creating publication quality figures, I might click on, a couple more sequences here. I might choose to remove the patterns for now, and then assuming everything I want is there, maybe include the domain structure alignment here, I'll click on view mode. And view mode just removes the UI elements here. So if I want to use a little snapshot button on Mac or snipping tool on Windows, I can take snapshot of this entire sequence alignment or particular portions of this sequence alignment. Additionally, I could download, right-click, and save image as, and I'd be able to download each of these individually to save them and put them in Illustrator. With that wraps up GTXplorer. We're trying to make this website more intuitive and more accessible. So if you have any feedback, you could post an issue on GitHub or email us directly at rtajale@uga.edu. If you want to cite us, this paper is still in the process of being submitted, but we will post the citation links up here soon. The phylogenetic tree and alignment information presented here were derived from our eLife Sciences paper, which will be located in the video description. Thank you so much.